Hello and welcome to this edition of 24 Hours to Pass, SQL Server 2014. We're excited that you could join us for Jimmy May's sessions on Columnstore indexes in SQL Server 2014, flipping the DW faster bit. This session was originally delivered during our 24 Hours to Pass event. Due to some issues with the recordings, we're recapturing this session to bring it to you. My name is Vicki Van Dam. I'm the project manager for PASS. I have a few quick introductory slides before I hand the reins over to Jimmy. He'll speak for about 40 to 45 minutes, and then we'll review some of the Q&A that was asked during this session. Next slide, please. Next, I'd like to bring your attention to the upcoming PASS Summit. This will be taking place in Seattle, Washington from November 4th to 7th. PASS Summit 2014 will feature over 200 sessions with world-class SQL Server experts. This conference is planned and presented by the SQL Server community for the SQL Server community. PASS Summit is single-handedly the largest gathering of SQL Server and BI professionals. With over 5,000 attendees from all around the world, PASS Summit is also a great place to network and meet face-to-face with experts, peers, and MVPs. More importantly, PASS Summit delivers on providing you with the answers to your SQL Server issues, along with the knowledge, strategies, and skills you need to stay ahead of the curve. You can contact one of our chapters or virtual chapters to access one of their discount codes. To find out more about PASS Summit, please visit us at www.passsummit.com. Next slide, please. I'd like to take this moment to thank our event partner, Microsoft, who is one of our global sponsors. The staging of 24 Hours of PASS would not be possible without their support and dedication, and they are the reason that we are able to bring this event to you free of charge. And with the next slide, I will introduce our speaker, Jimmy May. Jimmy is a Senior Program Manager for BPD CX SQL Server Customer Advisory Team, otherwise known as SQL CAP. He manages the SQL Server Customer Lab, and he's the founder of 2 user groups. You can see his Twitter handle there, and he currently resides in Redmond, likely close to the Microsoft campus. Jimmy, welcome, and I'll hand the reins over to you. You may just need to unmute yourself, Jimmy.
Thank you, Vicki. I appreciate the great introduction. And I am Jimmy May, and thanks everyone for joining. Columnstore indexes were introduced in SQL Server 2012. They're gaining traction, yet they're still largely unknown. In 2012, some adoption blockers existed, yet Columnstore is nonetheless a game changer for many apps. In SQL Server 2014, many potential blockers have been removed, and they are profoundly changing the way we interact with our data. My purpose is to educate you on Columnstore, convince you they're a compelling reason to upgrade to SQL 14. In fact, after this presentation, I hope you're wondering, why haven't I already started experimenting? A little bit about me. Objectives and takeaways. Columnstore indexes can enhance performance, check this out, by 1, 2, and sometimes even 3 orders of magnitude. Imagine that, query performance up to 1,000 times faster. Not always, of course, but it is possible, and we have seen it. And you're going to understand after we finish the disadvantages, the advantages, limitations, the pros and cons of implementing Columnstore in 2012, and especially the new significant improvements in 2014. And the big takeaway, the call to action, is that at the end of this presentation, I hope you're compelled to check out Columnstore for yourself and actually start digging in and start experimenting. Those of you who are familiar with me know I am passionate about performance. This is a meme on my blog, Flipping the Faster Bit, and I know I share this passion with many of you. We aren't just here to collect a paycheck. We're here to actually delight our customers, delight our users, and the motto, courtesy of Hugh McLeod of Gaping Void, hey, let's change the world or go home. I have a whole lot of people that have contributed to this deck, which has evolved over the last couple of years since SQL 2012 was in beta. Many of you worked with Denali. This slide used to be at the end of my presentation, and I just frankly never got to it. These people need to be acknowledged, and at the very least, I would like for you to see their names. So thank you, everyone. So we're going to jump into a quick overview, talk a little bit about the architecture, dive into the distinctions, the very important, sometimes subtle, but important distinctions between 2012 and 2014, Columnstore-wise. Talk about implementation. I'm going to provide you the information you need to hit the ground running. And given the time, I have some real life case studies that I'm very, very excited about sharing with you. Okay, hey, let's dive right into a demo. And this is a lot of fun. It's a very simple, straightforward demo. It's a special implementation of an AW AdventureWorks database where we have taken a partition table and expanded it to 100 million rows. And by the way, those of you who have maybe listened to this presentation or similar ones in the past, I used to do this like 45 minutes into the presentation, and by that time, people were snoozing. I do it up front now, just to show you the power of Columnstore. So let's do a row count on our table here. As you can see, 100 million rows. And just to make sure we're playing fair, we're going to drop pages from the buffer pool. Got it? I've already had statistics time and IL on. There we go. Just to double check. I'm not going to create this index because I've already done so. But as you can see here, just to give you an idea of the time it takes to create a Columnstore index, on this 100 million row table, it took about 5 minutes on spinning media and almost 4 minutes on SSD. So here's the query. Relatively simple yet classic data warehouse query, classic star join. And you notice there's a hint at the end, an option, ignore non-clustered column index. And what this is, it's just tells the optimizer, hey, there may or may not be Columnstore indexes on the tables involved in this query, but if there are Columnstore indexes, I would like you to ignore them for the purposes of executing this query. And the purpose of this, of course, is to show you the performance of Columnstore using classic structures. So let's let this run. And so now here we are, we're running it. And it's running, and it's running. And if this were live, and Vicki mentioned earlier, our moderator, that this was a re-record. You may wonder why we had to re-record it. Well, there was a copyright issue. Those of you who know the show Jeopardy, I would play the da-da-da-da-da-da-da theme during this while we are waiting. Well, we can't do that today. So, and also at this time, I would be asking the audience questions about, hey, who's implemented Columnstore? Who has challenges with resource performance? Who has queries, especially report queries or aggregations that are running slowly? And I would engage you at that point. Okay, that having been said, we have an answer. And as you can see, this query took 31 seconds to run. Let's dive into the output of the statistics commands. And there we go, elapsed time of 31 seconds. Note the CPU time here. At this point, if this were live, I would be asking people, hey, why is CPU time 100 seconds? And invariably, a clever person in the audience would say, hey, because of parallelism. And that's exactly right. Whether conventional queries, data warehouse queries are being run, or we're leveraging Columnstore. SQL Server takes advantage of parallelism when it can. Bottom line, we have a duration of 31 seconds here for this query using conventional structures. Now let's rerun this query. And this time, I'm not selecting the ignore Columnstore index hint, and we're going to let the optimizer choose whether or not to use Columnstore. I'm sorry, before we do that, again, just to make it fair, let's drop pages from the buffer cache. Now, if the Columnstore index is used, it won't use those pages because the Columnstore index in this example is non-clustered and it uses a different set of data pages. But again, just to make it fair, to demonstrate there's no sleight of hand going on here, I've dropped the buffer cache. Now I'm selecting the query, Again, letting the optimizer choose to use Columnstore if it chooses to. And here we go. No time for the Jeopardy theme here. As you can see, this query ran and reportedly in about 2 seconds. That's versus 31 for the conventional structures. Let's dive into the statistics. 2.3 seconds versus 31. No tricks here, folks. That's an increase in performance by approximately, doing the math in my head, 13, 14, or 15 times. Not too bad. Raise your hands, folks. Anyone out there who wouldn't be happy with an increase in query performance simply by applying a single index and increasing your performance by an order of magnitude. Okay, you know what? As a DBA, someone who's been out in the field many times, I'll take that anytime I can get it. Okay, that having been said, I hope you enjoyed that demonstration. Let's go back to the previously scheduled slide deck. So what is Columnstore? Some of you, especially those of you working in BI, know the codename Apollo family. Columnstore is just another extension of our in-memory family of technologies with which a lot of you are familiar. Why is it called Columnstore? Well, SQL Server has had row store for a long time. You may have heard the term row store. We tended not to use it because we didn't have the juxtaposing column store. And now we do, and we need to make that distinction. What makes Columnstore Columnstore? Conventional data pages hold values from a tabular object for all columns. So a given data page will have a variety of heterogeneous data in it. Ints, dates, varchars, etc. Numerics, etc., bits, whatever. Whereas all the data on a Columnstore data page will have columns only for a given column. We'll talk more about that in a moment. And again, I've referred to doing this in live. This presentation is a lot of fun to do live. It's fun to engage people one-on-one, to ask the audience questions and get engaged. I recently performed this presentation at the SQL Server 2014 launch event in Redmond, SQL Saturday 306 in fact, and I had my sidekick, Wingman Shari Hashimi, demonstrating row store for us. And in this case, I pointed to his head and said this would be corresponding. So Shari is a data page. His head is column A. His shoulders are column B. His torso is column C, for example, et cetera, et cetera, et cetera. And I use the expression Columnstore pivots SQL Server storage on its head. And literally, that is what happens. So there I am demonstrating how Columnstore stores data. Every value, if my body corresponds to a data page, every value on that data page corresponds to data from a single column. So what are the high-level characteristics? Because the data is homogeneous, Columnstore storage lends itself to even greater compression than classic SQL Server compression, even greater than page compression, approximately 2 times as much. The engine has a rich and robust history of aggressively reading ahead, fetching data pages from disk, putting them into the buffer pool, anticipating what pages the optimizer / engine needs, and getting them into the buffer pool for quick access. And that's no different for Columnstore. And by their very nature, warehouse-type queries need to access large blocks of contiguous data, so it's a relatively straightforward matter for the engine to anticipate what's needed and read those pages into memory. Some of the competitors, so for example, Sybase, uses Columnstore, has long had Columnstore. In fact, we talked about Columnstore. We introduced Columnstore at least partly, is because of a competitive need to do so. However, the competitors haven't integrated the aspects of memory and disk in the way that Columnstore implementation in SQL Server has. We play very nicely. The program team has done a really, really great job of integrating Columnstore and not having it to be all held in memory, but to be able to read it off disk, anticipating the pages that will be needed. Again, part of the aggressive read-ahead algorithm that's used, and integrates it nicely No surprise to most of us here. Columnstore is processed in units called batches. SQL Server is a set-based relational database management system. And we all know, most of us know that SQL Server likes to use big chunks of data at a time. And for those of you coming from the programming world, it's often a big challenge. We've had to change our mindset, the way we manipulate data, the way we write queries from a row-by-row cursor-type process into set-based querying. No different in Columnstore. By default, when the stars are aligned and Columnstore works like it's supposed to, it works on 1,000 rows at a time. And those units are called batches. And it manipulates these batches using a mechanism referred to as vector-based query execution. That, to me, when I first heard it, sounded like a very exotic term. What exactly does that mean? Let me tell you a little bit about that. These 1,000-row batches aren't manipulated explicitly in the processor like conventional row sets are. In fact, pointers are created that correspond to these 1,000-row batches, and it's those pointers that are manipulated in the processor. In fact, in the L1 cache, and one of the many optimizations that lends Columnstore to very high performance. So instead of the data itself being manipulated by the processor, pointers to that data are being manipulated. And this is almost like magic. When you create the Columnstore index, the optimizer decides whether or not it's useful for a particular query. It's automatically considered. No changes to the application are required. It is just a wonderful thing. No changes to the code, no changes to the application, nothing else is done. You create the index, and the optimizer decides to use it or not. And this stuff just wasn't bolted on. Numerous deep engine modifications were made in many aspects of the engine. And that work continues going forward. It's one of the most important areas of improvement, in fact, that the program group is undergoing at this time. Why do you use them? Okay. If we're looking for a subset of columns from one or a few rows, given the right indexes, SQL Server can do a superlative job of providing an answer. In fact, for well over a decade, SQL Server has done a great job of answering queries that only required access to a few rows. But if we're asking a question, which by design needs to hit a lot of rows, reporting, aggregations, grouping scans, etc., SQL Server has never had a good mechanism to do so until Columnstore. Why else use Columnstore? What does this bullet mean? Faster interactive query response time. Imagine user queries that take minutes to run. Not fun to play with. We have a user who executes a query and they cannot expect an answer for a number of minutes. You know, that's a bit of a challenge. It's a multitasking opportunity. It's a chance to change context. It's a chance to lose focus. It's a loss in efficiency. What would happen? Imagine a world where a query that takes 2, 5, 7, 10 minutes to run can instead return results in seconds. Folks, this is what Columnstore can do, potentially. And we'll show you some examples. As I said earlier, stuff just works. It's transparent to the app. Columnstore is orthogonal to the many other aspects of the engine. You just create it and let it rip. This is an important consideration, reduce physical DB design effort. This is really pretty exciting. This is one of the most exciting aspects of Columnstore. I mentioned a moment ago about the faster interactive query response time. Many of us have been involved in the pros and cons of designing queries. You know, covering index, the determining leading keys, the compromises we have to make. We can't put in a limited number of indexes on a conventional table, etc. But check this out. Consider the case in which a report query in your data warehouse has gone rogue, and your former indexing strategy in place for months or years has worked great. Then suddenly, instantaneously, Historical response times increase dramatically. The usual quick fixes, updating stats, don't work. Your flagship app has slowed to a crawl. Hey, I know some of you have been in this scenario. Managers are looking over your shoulder, maybe breathing down your neck. You realize you're practicing in front of the CIO trying to fix this. A war room may be called. Hours, sometimes days, are spent balancing competing interests, such as column key order, the number of indexes, how wide they are, the queries they cover, etc. And that's the world we have lived in historically. Now imagine a world where it didn't have to happen that way. A world in which no index tuning is required, where one index worked for every query. Can you imagine such a world? Welcome. Welcome to the world of Columnstore. Look, folks, I don't want to paint too rosy a picture. Sometimes column stores don't work the way we want, but I got to tell you, sometimes and very, very often they do. And when they do, it's truly a game changer. And so what does all this mean? Lower TCO. Yeah, I know that's a marketeering term, but yeah, I had to say it because the impact is that significant. Okay, we're going to talk a little bit about the architecture now. And by the way, I hope I have piqued your interest. You've seen a little bit of a demo where I've showed you 12, 13, 14, 15 times improvement in a fundamentally simple query. We've talked about a compelling world in which Columnstore can change the world in which your users live. We've talked a little bit about why we would use Columnstore. Let's talk a little bit about the architecture. Sunil, by the way, had a great session. He did a technical deep dive just prior to my delivery. So this presentation, the purpose of which isn't to go nearly as technically deep, but to give you more of an overview and to provide you the incentive to walk away and think about implementing Columnstore yourself. Okay, so what are the internals like? We are probably, most of us, familiar with classic B-tree structures. We talked earlier about how Columnstore storage literally flips the internal storage of data on its head. I'm going to talk about a little bit here about how Columnstore is created internally, and some of these terms will be reused, but they're fundamentally very simple, and I hope you can don't overcomplicate them. I hope you can wrap your heads around them quickly. So we issue a create index statement to the engine, and what the engine does is grab the first 1 million rows, and we're doing this in parallel actually, so it'll actually identify multiple sets of 1 million rows, 1 million logically contiguous rows, and simply horizontally partitions those rows. The next step that the engine does when a Columnstore index is created is to vertically partition each row group into simply the constituent columns. Thirdly, and that's called a segment. A segment corresponds to values for a single column in a given row group. And thirdly, the segments are compressed and they're stored in separate blobs. And when rows are needed from a given segment, that entire segment is loaded into memory. Now, you might think, I need values for one row, and I've got values from 100 million rows thrown into memory. Well, keep in mind, Columnstore isn't designed for OLTP type queries, OLTP type applications. Columnstore, by its very definition, is created to optimize warehouse type queries, aggregates, reports, things that by their very nature access multiple rows. So you're seldom going to leverage a Columnstore, at least not per best practice, to access data for one row. You're accessing Columnstore when you by design, by intention, need to access values from hundreds of thousands, millions, hundreds of millions of rows. And so loading a segment into memory is probably what you want to do. And that's what the optimizer does. Let's go through a very simple prototypical example. I'm going to walk through those very same 3 steps that I just talked about. So here we have a prototypical data warehouse query, or excuse me, data warehouse table. Instead of a couple dozen rows and a half a dozen columns, let's pretend this is a real life table. We've got 100, maybe hundreds of columns, and hundreds of millions or billions of rows. So use your imagination here. What's the first step that I talked about just a moment ago? We horizontally partition that large table into 1 million row groups. The second step, we vertically partition. When I say we, the engine does this under the covers, vertically partitions the data into its constituent columns. Lastly, we compress each segment. As you can see, some columns are going to compress better than others because the data is more homogeneous. A date column, for example, in a warehouse, one value may correspond to an entire segment. Other data is going to be slightly more homogeneous. And by the way, something here that is very important, and I'll bring it up later, per best practice data warehouse design, your join keys, your foreign keys are on integers. This has been a best practice for data warehousing for well over a decade. It isn't just a Columnstore optimization. However, Columnstore leverages joins on integer data types far more efficiently. And that's something you'll need to keep in mind. And again, we'll talk more about that in a moment. Okay, so we've done a high-level deep dive. I don't know, is that a shallow dive? Into the architecture of Columnstore. I will remind you, for the technical deep dive, access Sunil's presentation, which immediately preceded mine. Let's talk about a very, very important topic now, and that is the differences between implementation of Columnstore in SQL Server 2012 versus 2014. This particular slide references, this applies to both 2012 and 2014. Columnstore indexes are not directly compatible with these structures. Index views, filtered indexes, sparse columns, or computed columns. And that means non-persistent as well as persistent computed columns. Oh, you might say, but we need those. Keep in mind, be mindful, these structures are workarounds for performance and are largely rendered moot by the performance of Columnstore. So if you feel sad now, just wait till you install Columnstore for yourself and see what happens, and see if you still need these structures. Okay, now I'm going to dive into the caveats related to 2012. In 2012, Columnstore indexes are limited to non-structured indexes only. An underlying B tree is still required. Whether it's a heap or a clustered index, you need a base table to create a Columnstore index in 2012. I mentioned a moment ago about the importance of integer-based keys for joins. In 2012, and this applies to some extent in 2014, you may have to modify your schema. And one of the most common things that we see that needs to be done is to factor out joins on character columns and instantiate integer-based foreign keys. And in fact, my very first experience with Columnstore, Denali, pre-production bits, I had a customer in the customer lab, and we had to refactor the entire application in order to take advantage of Columnstore. The differences were profound. We went from really, frankly, pretty dismal performance in this early build of SQL Server to profoundly fast performance. And it may seem like an ordeal to refactor your application in that way. In this case, and in many cases that we've seen, eminently worth it. Next bullet, and almost all of you are probably aware of this, in 2012, Columnstore was a read-only structure, is a read-only structure. There were some workarounds, and it was actually pretty trivial, just a specialized implementation of partitioning. And keep in mind, be mindful as you read this, Columnstore by design is used to optimize data warehouse queries. And having a read-only structure in a data warehouse isn't a big deal. You're not updating that data every minute, every hour. You're updating it commonly on a nightly basis. So this read-only restriction was in many, many cases not a big deal. In 2012, there were some, in 2014, some memory optimizations have been made. The way memory is managed to implement it to Columnstore index is far superior in 2014 versus 2012. Keep in mind, you're creating an index across dozens, over 100 columns sometimes, so it probably isn't too surprising. That takes a lot more memory to manage than creating an index off of 3, 4, 5, half a dozen, even a dozen columns. We ran into out-of-memory errors not infrequently. I've got a demo later. Hopefully we'll get to it, where I show you a little bit of how to work around that. The workaround is trivial. The important takeaway here, if you're working on Columnstore in 2012, is to anticipate the possibility of memory errors and know how to work around them. So don't be scared if you run into that. Trivial workarounds. Enterprise edition only, probably not a big surprise, and though it's on the roadmap to implement Columnstore and make it available to us in our PaaS and SaaS applications, for now it's only available in the cloud for IaaS implementations. And in 2012, though the team did a great job of implementing data type support, it's not complete. It wasn't complete. In 2012, ints, reals, strings, money, datetime, decimal, less than 18 digits are supported, but decimals greater than 18 digits, binary, var binary, CLR, any blobs, datetime offset with high precision weren't supported. In 2014, everything except blobs are supported. Everything except CLR, invarchar max, var binary max. XML, spatial aren't supported, but everything else is supported. The team did a great job of data type support in 2014. Okay, here's a pretty important slide. It's always been a good design practice to build your data warehouses based on a star schema. That is especially important in 2014 because the optimizations built into the engine are designed to leverage star schema. In general, it's a great idea to build your Columnstore index on your fact tables. These are, as most of you probably know, the tables that grow on a daily, hourly, sometimes minute-by-minute basis. Sales data, for example, presumably in a successful enterprise, grows rather quickly, as opposed to your dimension tables. Dimension tables tend to grow significantly more slowly, though some dimension tables can be large, and some dimension tables can benefit from Columnstore. I actually have a query, hope to publish it soon, where I examine the usage of indexes in your warehouse, in your application, and help you determine whether a table, fact table, or dimension table may be a candidate for Columnstore. I mentioned this. This is now the third time. It's important. Integer surrogate keys for joins to dimension tables. I guess it's possible to overemphasize that, but you need to walk away being aware of how important that is. I mentioned earlier about the minimal DB design effort, how one index, it's a big index, but this one Columnstore index can literally take the place of all the index tuning we've done in the past. And that's literally possible. I want to share once again, that isn't always the case. Columnstore doesn't always work the way we want it to. But folks, when it does, and it often does, it's tremendous. You just write the queries and they work. I'll talk a moment more in a moment about a cluster Columnstore object versus 2012, which only had a non-cluster Columnstore available to us. Something to consider here. Whether you're talking about a cluster Columnstore or a conventional table, logically there's no difference. Logically there's no difference. They're just the same. Of course, under the covers, they're significantly different. I mentioned a moment ago, and as again most of you know, Columnstore in SQL Server 2012 was a read-only structure. In 2014, Columnstore is writable. Now, some people think that this is the most important thing in Columnstore. People salivate when they talk about, oh yeah, I can finally write to my Columnstore index. Okay, it's non-trivial. I think it's great that we can do that. But I'll have a slide later where I talk about what I believe is something that's far, far, far more important than the fact we can write to Columnstore. I will also explain later a very important caveat, something you need to be aware of if you're writing on a regular basis to your Columnstore indexes. Frankly, something we as Microsoft need to do a better job of getting out there. So yeah, Columnstore in 2014 is a writable structure. Big takeaway here. Classic partition switching and bulk insert remain best practices for loading a Columnstore object. Be mindful of that. I mentioned the data type support was significantly expanded in 2014, and it is, and that's nice. Cluster column store, no dependency on an underlying clustered index or underlying heap. This has an important ramification in terms of disk savings. So imagine you have a base table, and imagine you have this other object, this non-clustered column store object, that is comprised of basically all the columns in that table. And you might have a handful of non-clustered conventional indexes as well. Even compressed, that's a lot of space that we're talking. Imagine replacing all of those structures with one clustered object. We find space savings on the order of twice, 2, 4, sometimes more. Okay. Now we used to say disk space is cheap. The fact is it's not. And even whether it's cheap or not, space can be limited. And a lot of you, I know, spend a lot of your time moving bits around to try to make space. A clustered column store object can go a long way in mitigating some of those challenges. And by the way, even though in 2014 we have a clustered column store object that replaces conventional structures, we still support a non-clustered column store in 2014. So if you want to create a non-clustered column store in 2014, you can do so. It's still read-only. And why would you want to do this? Well, constraints, which are enforced in SQL Server by indexes, require an underlying B-tree structure. So if we don't have that, we can't create the constraint. And sometimes, as magical and as wonderful as Columnstore can be, as much of a game changer as it can be, there are some queries that still don't get the Columnstore love, that the optimizer can't recognize and use the way we would like. And in those cases, if your workload isn't quite compatible with Columnstore, you may need non-clustered indexes to help support that workload, and you may be stuck with using a non-clustered Columnstore index in 2014. So we keep that option available to you. I talked about batch mode a little while ago. SQL Server wants to use batch mode. It wants to grab 1,000 rows at a time that are processed very efficiently in the L1 cache of the processor through pointers. Well, that batch mode, the opportunity to leverage batch mode, has been significantly improved in 2014. Also, we have support for many more optimizer operations and functions. Folks, I mentioned a little while ago that yes, it's cool, it's great that in 2014 Columnstore is writable. But right here, these changes to the optimizer, these improvements to the way the optimizer can use the vastly expanded opportunities we have that the optimizer has given us to leverage Columnstore, this, my friends, this is the single most important improvement for Columnstore in 2014. This is our big takeaway. A lot of queries in 2012 simply didn't work the way we wanted. In 2014, that has changed significantly. So yeah, again, writable is cool, but the changes to the optimizer, the significant improvement to the optimizers are really the big deal in 2014. Okay, let's walk now into some implementation. And by the way, at this point, I would have given people an opportunity to ask questions. Please, my email is listed on the deck. You can go to my blog, email me, tweet me. If you have any questions after listening to this, please reach out. I invite your questions, and I promise to get back to you. So let's talk about implementation. We've talked about how cool Columnstore is. We've talked about some architecture, some of the great things about Columnstore. I've shown you an example. Well, how can you implement Columnstore? How can you go from this presentation to actually starting to use Columnstore? Look, I'm telling you, getting ramped up is relatively straightforward. And I'm going to prove that to you. To create a Columnstore index, so simple. For a non-clustered Columnstore index, you add one keyword, and you add the column, and everything else is the same. For a cluster column store object, we mentioned the cluster column store. Well, by definition, a cluster table is the object, is the data. Hey, check this out. The engine knows what columns are on your table. You don't need to add a column list. But bottom line, the syntax is simple. The drop index syntax is exactly the same. To enable or disable the index is exactly the same. A couple of hints, you've seen one of them. If I want to force the optimizer to use an index for whatever reason, the optimizer chooses to ignore a column store index, we can tell the optimizer, let's check it out, let's enable stats IO and stats time, force the optimizer to use it, and see how the stats turn out and figure out why. Frankly, I have never seen this happen. I have never seen the optimizer not use an index, a clustered or unclustered column store when it was supposed to. It always makes the right decision, in my experience. And as we saw earlier, if you want the optimizer explicitly to ignore a column store index, and the most common use of this is when we're doing before and after comparisons, without comparisons, this is the hint we use. So I've just gone through a handful of statements that introduce you to the DDL, the DML, the DDL related to column store indexing. Fairly simple. No rocket science here, right? You now have the information you need to experiment with column store yourself. And hey, you know what? Let's toggle over and we'll build an index. Again, I'll show you how easy it is, and at no extra charge, I'm going to show some of you, I'll show all of you, a little trick some of you may not know yet. Okay, let's make sure I am in the right database, and we are. And we are going to build an index. Let me scroll down a little bit here. Okay. You saw the syntax just a few minutes ago. And we're going to fill in the blanks here. So I've already scrolled and exposed the object here. Let me change that selection. So I have the object here on which we're going to create the DDL for an index statement. Now many of you are familiar with dragging and dropping from Object Explorer to the editor window an object such as I have just done. I've just dropped a table name into the editor. No big deal. Who hasn't seen that? But what about that comma delimited column list that we want? Because keep in mind, in a real warehouse table, we may have hundreds of columns. Sure, so we can type them manually. We can maybe do something fancy with sys.columns. But let me show you an easier way. So you saw me just a moment ago, something we've probably all done, dragged a table object over, and that pasted the name. Now, though, I'm going to do this. I have exposed the columns node. I'm dragging that over. I'm dragging that over. All right. I'm dragging that over. There we go. And I'm dropping it. Everybody see that? Bingo! Simply dropping the columns node produces a column delimited list of every column in the table. Ta-da! Thank you, thank you, thank you very much. All right, and at that point, we simply select the statement and we execute it. A moment ago in a previous slide, I mentioned the syntax for creating a clustered column store index. No column list required, because by definition, as we have discussed, the clustered object is the data. The engine doesn't need to be told what columns are part of that table. So we simply execute this statement, adding the clustered column store statement. Okay? And so there we are. There's our DDL for creating a non-clustered column store object and creating a clustered column store index. And truly, I mentioned it a moment ago. You see how simple it is? Now you really do have all the information you need to start rolling on using Columnstore. Okay, building them fast. This is some important stuff. I wanted to talk about it very quickly. Just some stuff you need to be aware of. I have mentioned the potential for running out of memory in 2012. It can happen. It often does happen. Not a big deal. We're going to come to another demo very, very quickly, and we'll talk more about that. In 2014, there are some dynamic memory enhancements that have been implemented, and I have yet to run out of memory. Even when I tried to create a demo to run out of memory, so I could demonstrate what to do in that case. I was not able to succeed. The engine has done that good a job of managing memory. Like all indexing, whether conventional or non-cluster column store or cluster column store, parallelism is leveraged significantly, and in the case of column store, the unit of parallelism is a segment. And if you're running a big query, you have lots of potential for parallelism. Low memory can mitigate the opportunity to use parallelism. We're going to talk a little bit, and again in this demo, about how to change these memory settings that the optimizer can use to leverage column store. One workaround is simply add, hey, let's throw some hardware at it. You just simply add more memory to the system. You can also adjust the degree of parallelism settings either within the query or in the configuration options of the server. You can also manage segment size. I mentioned it a little while ago. By default, when you create a column store index, 1 million row groups are created. Hey, but if you're doing batch inserts, bulk insert to load column store, the size of the bulk insert determines the size of the row group. And if we have time, I'm going to dive into that a little bit more. In the meantime, here is an example. Column store, like all indexes, loves parallelism. This is an example of creating a column store object on my laptop. It leverages it. I didn't use maxstop, hint, in the query. And in this case, the SQL Server engine decided to use all 8 processors to build my index. And again, this is true for any index, conventional or column store. So be aware. We're here. Here's another demo. I'm going to do a time check real quick. Okay, running out of time as I see. Let's get through this demo pretty quickly, but it is a simple demo. I mentioned using Resource Governor to leverage the amount of memory that you allow the optimizer or the engine to use when creating a column store index. Those of you who may not be experts at Resource Governor may or may not know that whether we use it explicitly or not, the Resource Governor is on under the covers. Also by default, the SQL Server, when creating and executing any query, including a create index query, even on a quiescent server, will never use more than 25% of the memory allocated to the server. And why is that? If your server is doing nothing, why doesn't it just grab all the memory? How does the server know what requests may come in subsequent to that index create statement? Okay, so by default, no more than 25% of memory is allocated for any given query. But we can modify that. So let's suppose we have a maintenance window, and well, let's just run over to the demo, and I'll talk about it there. Okay, so let's suppose we know that we run out of memory when we're creating this column store index. Or let's say we just want it to be created faster. We have a little bit of a maintenance window. Here, for those of you, whether you're an expert at Resource Governor or not, whether you use Resource Governor or not on a regular basis, even if you've never used it, here is a very simple command to change the default, and I just executed it and it completed, to change the default Resource Governor settings to 50% from 25. And now you have twice as much memory to build your index as you did before. And again, if you know, if you're doing this explicitly, you know you have a maintenance window, you know it's maybe a time during which the workload is relatively trivial compared to production hours, for example. You can do this as part of a batch. It's a runtime configuration. You can do stuff, for example, create the index, and it'll be, since you have more memory, you know, what process in SQL Server or any Windows application doesn't love more memory? You create your index here, and when you're finished, you simply restore the Resource Governor settings to their default memory grant percent of 25. Okay, so here I've shown you how, on the fly, as part of a batch process, to manipulate the amount of memory SQL Server allocates in order to build your column store indexes more quickly. And by the way, this technique isn't limited just to building column store indexes. You can use this for any maintenance process that you'd like, or for that matter, any query that you'd like to give more memory to. Again, it's a server-wide, runtime operation. Easy to do. You saw how easy it was to do on the fly. And so I enabled it, changed it back. Blink of an eye. So there's that demo. So now you're experts not only at creating column store indexes, but also an expert at leveraging Resource Governor to do so. Okay, running out of time. Would love to talk more about this. So I'm just going to tease you with some information about the tuple mover and the way in which column store indexes leverages how it implements its writability. When you insert, update, or delete one or anything less than 100,000 rows in a column store index, those rows go into something called the delta store. And every so often, the tuple mover wakes up and asks itself, hey, do I have rows in the delta store that are eligible for being transmogrified to a full-blown column store object? And if it sees a sufficient number of rows in the delta store, it does so. The segment is temporarily locked. The update occurs. It typically happens very, very quickly. And then you have a full-blown column store. Now here's the problem that can happen with writing to the column store and not being aware of the internals. I'd like to say a lot more about the tuple mover and the internals and how it works. We'll have to reserve that for a different opportunity. But here's what happens when you're not aware of those internals and you're waiting for that tuple mover to wake up. I was called in to do some troubleshooting. We had a problem with query performance, a query that historically had run very, very quickly once column store had been replied, gradually degraded, and was taking over an hour to run. So this wonderful, wonderful column store creation was giving people fits, and they didn't know what to do. Now, at the time, they were also experimenting with Hekaton, so they thought maybe this is an orthogonality problem, maybe column store isn't playing nice with Hekaton. Turned out it had nothing to do with that. The application was leveraging 1,000 row inserts. And for most of us, we would think, hey, that sounds like a great idea. It's far better than single inserts, right? Well, it turns out because of the way writable column store works and the way the tuple mover works, well, we ended up with a bunch of thousands, quote, open row groups. These were row groups with delta stores that weren't full-blown column store. They were just basically mini B trees within each segment. And that turns out to be very painful. The remedy, which I was able to recognize, fortunately, very quickly, was to rebuild the column store index. I also suggested that they leverage far bigger inserts, and they chose to leverage 100,000 row inserts instead of 1,000 row inserts. And in the case of this application, that was consistent with their concurrency, and they were able to do so with no loss of concurrency. We went from 4,000 row groups to 522 row groups. Query performance went from over an hour to 23 seconds. That's an increase in performance by over 2 orders of magnitude. Big takeaway here. Very, very important takeaway of this slide is be cautious with the way you leverage writable column store. As I said earlier, partition switching and large bulk inserts remain a best practice. Do not take advantage of small inserts or ad hoc inserts, updates, deletes to column store. And this is something we need to do a much better job of evangelizing. Okay, next, I have a demo on table partitioning, which unfortunately I'm going to skip. It will be included. It's certainly available on my blog. You can use the Bing, search for me and Column Store, Jimmy May Column Store, and search on my blog for Column Store, and you'll find all kinds of stuff, including these demos. All right, I'm going to defer to my moderator now. Vicki, are you available? And I'm wondering if I can have 5 minutes to walk through a couple of scenarios.
Yeah, let's do that, Jimmy. Let's dive into a couple of the questions. So one of the questions we had from the last webinar was...
Oh, I'm sorry, Vicki, I apologize. Rather than diving into the questions, and I know we're running out of time, I would like to have just a couple of minutes to talk about a couple of scenarios.
Sure.
Can you indulge me? Thank you.
Yep, go ahead.
Okay, folks, I have some great wins here. I'd love to share them all with you. Let's talk about a couple of them. So I'm going to skip forward a little bit. I'm going to skip my case study with a great customer called Motricity. I'm going to skip a POC within MSIT, but I say skip, but let me just point out, you can see the numbers on the right, 56, 27, 20 orders, or 20 times improvement in various physical metrics. That's a good, nice takeaway. Here's a very important one I want to talk a little bit more about, a real-life customer. I talked about interactive query response time. They had canned queries, they had ad hoc queries. It was a painful situation. Oh, and to perform, even to get performance that they got as using the canned queries, they had to implement an SSAS infrastructure, and they had to learn MDX. They didn't like maintaining it. It was a hassle for them. The canned queries returned in 10 to 12 seconds. Not too bad. Most of us could live with that. But check out, after implementing Columnstore, those very same queries returned in a second, an order of magnitude faster. But here's the big win. Ad hoc queries. Before, these queries took 5 or 7 minutes, and these were, quote, real-life queries. We're talking people on the phone, dialing in. Customer support people had to run these queries and kill time for 5 or 7 minutes. Pretty painful. After adding Columnstore, bingo. Without exception, each and every query took only 1 to 2 seconds. 2 orders of magnitude faster. And folks, that's one of the game changers I talked about. And this is something that is not atypical when we implement Columnstore. Happens all the time. And here are some quotes from the customer. Very, very happy. And they got to deprecate their SSAS MDX infrastructure. Pretty cool stuff, huh? Those of you who have ever had a blue screen, that data is collected if you give us permission to. It becomes part of a 61 billion row table. This is 2012. They've leveraged Columnstore, and they now are able to answer queries that never before could they get an answer to, because they actually complete in a finite period of time as opposed to completing never. All right, lots more to talk about here, but we'll skip to this next very exciting win, and this is the last one I'm going to share with you today. Classic warehouse table, 151 columns, but it was pretty small, only 3 million rows. But check out the before and after metrics. Oh, yeah, you know, hey, raise your hand if this is a table you guys want to index for, all right? Okay, no hands, right? Simple query. This basically was a spreadsheet in SQL Server. There weren't any even column, any other tables to join to. Check out, this is the very same query, very same parameters, very same parameter values. The server was so resource choked that the very same query ran inconsistently. Look at that. If you're a user, you run a query, you don't know when it's going to return, from a half a minute to over 8 minutes. You add a Columnstore index, and bingo. Game changer. This query returns in less than a second each and every time today. Let's talk about some different queries related to that. The blue bars correspond to how things used to be. The red bars, which you may or may not be able to see depending on how close your eyes are to your screen, correspond to how quickly the Columnstore index queries ran. Now, just to make it fair, I changed this to a logarithmic graph, and in this case, every horizontal line corresponds to an order of magnitude improvement. In each and every case, every query ran 2 to 3, that is 1,000 times faster. This is in terms of duration, this is in terms of I/O, and this is in terms of CPU. Again, a game changer. I have other examples, both in my deck and also that I'll be posting to my blog. Takeaway, Columnstore can be a game changer. Columnstore can profoundly change the way we interact with our data. Folks, go home and give it a shot. That having been said, thank you very much. And with that, Vicki, let's field some questions. Thank you.
Great, thanks, Jimmy. I'm sure there's a lot more that people want to learn on this topic. Sounds like you've got lots of knowledge to share. So one of the first questions we had was, is /faster an actual startup option?
Ha! No, of course not. As I mentioned earlier, it's a theme on my blog. And one of my readers actually wrote into me and said, hey, my server won't start now. And I had to explain to the poor guy, bless his heart, that, hey, it's a metaphor. Anyway, so thank you for that.
No problem.
Vicki, next question.
Okay, why can the SQL Server 2014 clustered column store index participate in always-on availability but not readable on the secondary?
This is a great question. This has to do with, and actually a reader helped me answer this question, or one of my tweets. This has to do with the inability, the lack of support for snapshot isolation. And that's something that I hope we're able to take, to remedy, or mitigate at least, in future versions, future implementations. Next.
Okay, can you speak to the challenges related to the buffer pool and NUMA nodes?
Okay, NUMA is a wonderful creation, and goodness knows we're far better off with it than without it. Some of us have been paying from time to time by the way pages in the buffer cache are distributed across nodes. And when multiple nodes are involved, we of course have non-local access, which can lead to a variety of performance problems. That may require some troubleshooting. The way that Columnstore takes advantage of NUMA nodes and distribution in the buffer pool is, for better or for worse, exactly the same as it does for conventional tables. So we get all the wonderful advantages of NUMA technology, and concomitant with that, we have to pay a little bit of price in terms of the occasional disadvantage. I hope that answers the question. So NUMA in general is being leveraged and optimized, improved release after release, and let's hope we get some improvements. Next.
Do we need to rebuild Columnstore index often?
Another good question. We are going to work on a formal algorithm, just like we do for conventional indexes. When do we reorganize? When do we rebuild? And I mentioned, you saw earlier, the challenge we had with writable column store, and we had all of these small open, quote, open row groups. So we'll be providing some formal documentation soon. Bottom line is that it depends on how frequently your column store object is updated. Per best practice, you're switching in large partitions, and you have maximally sized row groups and optimal segments. If you are using small bulk inserts, or you're doing a arbitrarily large number of ad hoc inserts, updates, or deletes, you'll have to do so more frequently. And so the answer is really it depends. But if you are performing a best practice, data warehouse best practice of switching in large partitions on a, let's say, nightly basis, you may never have to rebuild your column store index. So there you go. Hope that is helpful. Vicki?
Thanks, Jimmy. Is there a limitation on the number of columns on a CCI, i.e. the number of columns on a table that contains CCI?
No. You're limited only by the number of columns that SQL Server can support in the table, as well as by your hardware resources.
Okay, great. Do you recommend to use Columnstore index in an OLTP environment?
Certainly, Columnstore was not designed for leveraging to be leveraged in a OLTP environment. By definition, Columnstore index are a wonderful creature when it comes to the kind of queries, as I have said earlier, that are characteristic of data warehouses / reporting. So if you're executing queries which by design execute need to access hundreds of thousands, millions, hundreds of millions of rows, you are very likely to benefit from Columnstore. If you attempt to leverage a Columnstore object on an OLTP database, you are may or may not get vastly improved performance. You're likely, based on my experience, to get no better or slightly worse performance. And in an OLTP table, you are exposing yourself, if you're updating, inserting, deleting rows in that OLTP table, especially on a frequent basis, you're exposing yourself to the possibility of the hazards that we saw earlier of populating the Delta store with an arbitrarily large number of rows, and you saw that performance degradation, that real-life application, how performance went from just a few seconds or a few minutes to over an hour. So if you choose to experiment with implementing Columnstore in an OLTP environment, be aware of the potential pitfalls and decide for yourself whether the advantages are worse than disadvantages. Thank you.
Okay, and the last question we have for you today, is it a good idea to physically order the columns to get higher compression?
Ah, wow, what a great question. This is something we are working on. We are working very, very hard on formal guidance. My friend, buddy, pal, Thomas Kaiser, formerly of SQL Cat, is a strong advocate of leveraging Columnstore indexes on heaps with no pre-sorting. However, we have seen cases where pre-sorting the tables can be very helpful. A key in this, and this is not just my own experience, but the experience of I mentioned that Watson application earlier, the 61 billion row table. By the way, if anyone knows Leroy Tuttle, collar him at PASS or something, and have him feed you some of the details, the goodness and the badness related to a 61 billion row table. They benefited very much by pre-sorting on their partition key, which was the day key. The program group echoes this information. The key here, as in any data warehouse table, is to shoot for partition elimination, independent of whether you're using Columnstore or not. If you can leverage partition elimination, by definition, you are going to enhance performance. And that applies equally well to Columnstore objects. So the answer is, at this point, I'm giving you some possibly conflicting information. No less than Thomas Kaiser says use heaps. We have some experience, however, that suggests basing your sorting on the partition key can be very helpful. We'll provide more definitive guidance as we learn more. Thank you, Vicki.
Thank you, Jimmy, and thank you for the great session. Thanks to all of our virtual attendees who are watching this recording, to our partner Microsoft, and